In this lesson today, we're going to be talking about similar polygons. In class today, we looked at similar triangles, and we found two properties that were true about similar triangles. And that is that corresponding angles must be congruent, and also corresponding sides must be proportional. Well, this is true about similar triangles, but it is also true about similar polygons. So any shape would have these same conditions. So polygons are the same shape, but they are a different size. Remember, angles determine their shape, side lengths determine their size. So polygons are similar if corresponding angles are congruent and then corresponding sides are proportional. The ratio of corresponding sides is called that number over some number is called the scale factor. Well, when else did we talk about scale factors? We talked about scale factors in dilations. Therefore, dilations with that scale factor 2-to-1 or 3-to-4 gives you similar figures. So if polygons are similar, then there's a property about their perimeters. Then their perimeters are proportional. Now, what is a perimeter? That's when you add up all the sides. So let's look at these scale factors. What is the scale factor of triangle ABC to triangle DEF? The order that we do these in here matters. Order matters. So we're going to do ABC to DEF. So ABC has to come first. So the scale factor of ABC, I'm going to pick a set of sides. It doesn't matter which side, they just have to be corresponding sides. So I'm going to pick side AB here. So AB is 8 over its corresponding side is DE. So I'm going to do 8 over 12. Okay, which I can simplify that. 4 goes into both of those to make it 2/3. That would be your scale factor, 2/3. Now, what if I ask you for the scale factor from DEF to triangle ABC, which means I'm going to have to start in DEF. Again, I can use any two sets of corresponding sides. Let's just do the same. This time I'm going to start with triangle DEF. So let's do side DE, which is 12. Over AB corresponds to it, which is 8. And then if I simplify that, that's going to give me 3/2. If you look at their scale factors, it's just the reciprocal. It's flipped. Because what did you do with the triangles? You flipped the triangles around. And then what's the ratio of the perimeter? Again, perimeter is when you add up all the sides. So the perimeter of DEF, I would take 12 plus 15, which is 27, and add 21 to that, which is 48. Over the perimeter of ABC, that is 24 plus 8, which is 32. And if we reduce that, that gives me 16 goes into both of those. That gives me 3/2. Now, if you see, since this went DEF ABC and the ratio of the perimeters was DEF ABC, the scale factor should be the same for the sides and for the perimeter. Now, similarity statements. We had congruency statements. We also have similarity statements. The symbol again for similar is just the squiggle. A valid similarity statement must match corresponding angles and sides. So if we write a similarity statement for these triangles, I could say that triangle ABC is similar, not congruent, because they are not the same size, Okay, ABC, angle A corresponds with angle D, so this is going to be triangle D. Angle B has 2 marks, so it corresponds to angle E. And then lastly, angle C has 3 marks, so it corresponds to angle F. Okay, now let's look at some sides, corresponding sides and corresponding angles. Again, we can get that from this triangle. In triangle JKL, again, this means similar to triangle PMN. I can get corresponding things from the pictures, but I can also get it from the lettering. So angle J is going to be, again, the angles, corresponding angles are congruent, so they're still congruent to angle J goes with P. Angle K will be congruent to angle K goes with M. And then angle L will be congruent. It's the last letter, so it will be congruent to angle N. Okay, sides. Again, if these are similar, then sides are proportional. So each set of ratios will be equal to each other. So side JK over its corresponding side JK is the first two, PM. That ratio has to be equal to KL over KL is the last two, so MN. And then that ratio has to be equal to JL over, that's first and last, so PN. All 3 sets of those ratios have to be equal. Here, let's look at 2. This is kind of like your triangles in your activity from today. There are 2 sets of triangles. We have triangle XYZ, this large triangle, and inside of it we have triangle RYS. So they are similar, which means angles are congruent. So we're going to write angle X is congruent to angle R. Angle Y is congruent to angle Y because it's shared in both triangles. And when we get into proofs, if the angle shared in both triangles, that's going to be the reflexive property. And then angle Z is congruent to angle S. Sides are not congruent, they are proportional. So I have to show that the ratios are equal. So I'm going to say side XY over XY goes with RY. And that's going to be equal to, let's see, ZY over its corresponding side is SY. And then lastly, XZ is going to be equal to RS. Okay, pause the video and I want you to try number 3. Okay, let's now go ahead and check your number 3. And then let's look at a few of these practices together. Number 4, if the figures below are similar with a scale factor of 2 to 3, find the value of X. So we're going to use their ratio here, 2 to 3, to set up a proportion. Oh, goodness. So that set of sides then would be 2 to 3. So I would do 3 is bigger, so the bigger figure is going to go on bottom, which will be X, and 42 is going to go on top. So now all we got to do is cross multiply these. 42 times 3 is 126, equals 2 times X is 2X. Then we're going to divide both sides by 2. So that's going to give us that X equals 63. So that is the length of that side. Okay, let's look at number 6 together. On number 6, we have triangle ABC is similar to triangle DEF. Find the values of X. So we're going to set up another proportion because sides are proportional. So I'm going to say AB is X over what side corresponds to AB. Again, if it's hard to see in the picture, look up here. AB goes with DE, so it's going to be over 25. equals, I've got BC, which is 28. Whichever triangle I start with and that's on top has to be on top in the other ratio. So 28 over, let's see, that's BC. So BC goes with EF, which is 20. So again, we are going to cross multiply. 25 times 28 gives us 700 equals 20x. Divide both sides by the 20. And that means x is 35. Okay, and now let's look at number 8 together. On number 8, triangle AGM is similar to triangle KXD. So again, we know that in similar triangles, sides are proportional. So we're going to have to set up a proportion. So we set up a proportion with sides that we know. So we know GM is 36 over side GM. GM corresponds to XD. Well, XD is x plus 6. We're going to set that equal to the other side that we know, which is GA of 32. If you start in this big triangle for your first ratio, then the top number has to be from that same triangle. And then GA corresponds to XK. Here's XK, which is x plus 3. And now we need to find the value of x. To do that, we are going to cross multiply. So I'm going to do 36 times x plus 3, so I'm going to put that in parentheses, equals the other cross product, which is 32 times x plus 6. And now I'm going to go through and I'm going to distribute. So I get 36x plus 108 equals 32x plus 192. Now I'm just going to solve this equation. I'm going to subtract the 32x over. That's going to leave me with 4x plus 108 equals 192. Subtract the 108 over. And I get 4x equals 84. Divide by 4. So x is 21. Okay, so I want you now to try numbers 5, 7, and 9. I've done one of each just like it. So you do 5, 7, and 9, and we will look at these tomorrow.